Hi guys, just getting you guys finished up here with the peanut lab. I'm going to go through those calculations for you. So I'm going to share my screen. Basically what you have here is you have two trials where you've taken the mass of a peanut and then you burnt the peanut and then you determine the mass of the peanut. So you're going to take the initial mass minus the final mass to get our burnt mass of peanut. So this is the mass that we're interested in, and this will be in grams. The volume of water came from the graduated cylinder in milliliters. So this came from the grad cylinder, and it's in milliliters. The serving size from the label was 28 grams, as you can see from the data table in the video. And the calories is 160 calories, and these are food calories. Okay, what we'd like to do is we're going to take the mass of the water. So we're going to take the mass of the water right here in both trials. And we're going to use the fact that 1 gram of water is 1 milliliter. And so basically the volume of the water is going to equal the mass of the water. So whatever you got up here for the, this is mass of the water. This is going to be, right here, milliliters of water. Sorry, I messed up there. This is the milliliters of water. We're going to put that here, but we're just going to change the units to grams. So this is going to be grams, and that's going to come from the milliliters of water. Okay, so you're going to do that twice, one for each trial. Okay, when we calculate the heat, basically what we want to do is we want to use this formula right here. So we understand that for every gram of water, it takes 80 calories. So we're going to take the mass of the water. I'm going to multiply it by 80 calories per gram. And that's going to give us the number of heat calories that we produced by burning the peanut. We're going to do that for those two trials. What we understand is that there's 1,000 calories in a heat calorie, or 1,000 heat calories in a kcal, and there's 1,000 calories in a calorie. So basically what we want to do is we're going to convert this number to this one by dividing by 1,000. So we'll get something point something, I don't know, something, some number, and it'll have a point in it. And then what we'd like to do is we would like to take and figure out the calories per gram. So we're going to do the calories from up here, and we're going to use the gram of peanut from up here. So this is the burnt mass of the peanut. We'll keep that green. And so we're going to divide the calories by that mass of the peanut that we burned. So that's what's going to go there. And then we're going to have a unit in calories per gram. We're going to average those two numbers together. So we take the calories per gram for trial 1, and we're going to add it to the calories per gram for trial 2. And then we're going to divide that by 2. So I'm going to try that again. This is trial 2. So we're going to add those together, divide the whole thing by 2 to get an average. I'm going to check to make sure that the number is in between your two trials, because that number in the middle should basically be in between the two trials there. When you go to get your calories per gram from the label, we're going to again we want 160 calories per 28 grams of peanut. And we'll get this value, and we're hoping that when we compare this average value to this calculated value from the label, that they'll be fairly close. And so what we're going to do is we're going to do that experimental difference, the difference again that we've done before. So basically we're going to take what you got up here, the calories per gram of peanut, your experimental value, the average of the two, that's going to go right there. And then the label says something else entirely, probably maybe a little bit higher, I imagine. That's going to go here and here. You're going to do the right order of operations, meaning you're going to do this subtraction first, and then you're going to divide by the calories per gram. You're going to multiply by that by 100, and you would like that to be less than 10%. But where is the loss of energy going? So I want you to think about that, right? It was a flame, and there was light, right? The air was heated, the can was heated, and you may have lost parts of the peanut on the counter, so there's lots of room for error here. So I want you to think about that. If yours are greater or less than the advertised, why might that happen? And then again, here's those reflection questions for you guys to complete. hopefully that works, and that would take care of our calculations for the energy of a peanut.